Hello, hello. So we were live. Right. So in this stream, basically, I thought whatever I do, I'm on a new journey with ESP32 and figure out कर रहा हूँ basically how does it work and embedded system basically. This is my setup and we'll learn as we go through. We all will run basically. And welcome to the stream. I think we have one viewer. Hello. Yeah, I think our setup is good. So what I generally do is बता देता हूँ थोड़ा मैं codex plot use करता हूँ generally to investigate and GPT for conversation. So I'll just set it up. This is my idea. This is my terminal where the full screen terminal. This is for discussion, so it will go here. By the way, when you are learning something, having a proper setup is definitely useful. And this is my ESP32 connected via USB to my laptop, and using UART, I'll be flashing whatever code I'm gonna write in here. And it's down below. ये रहेगा and this is my written code. Yes. Okay, this is my code. Perfect. So far what we have done is we have written a simple code, app main, and I flashed it. So in order to flash, you have to basically do IDF -p port flash monitor. So ये जो code है, all of this got flashed, and if you see here in the console, it says returned app main. But I was trying to figure out कि what happened, हुआ क्या exactly. So these are the files that got built in the via IDF tool. So what I did was, yes, this basically IDF size PY basically tells you जो कोड आपने लिखा है. तो होता क्या है कि मैंने ये लिखा सिंपल सा IDF, हाँ, बट think of it as like this कि वो हार्डवेयर है, right? And that hardware has what, 3 major components. One is your what this is here, right? This is on full screen. Yeah, so 3 major component है. एक अपना CPU है, dual core CPU एक्सटेंसा का, and one is RAM and another is flash memory. फ्लैश मेमोरी को ऐसा सोचो कि वो हार्ड डिस्क टाइप का है, एंड रैम है. तो अपने को हार्ड डिस्क मिला है 16 MB and flash memory है 8 MB. Now for computers or any microcontroller, even your laptop, it doesn't know shit, right? All it knows is memory 101010 binary, and CPU is basically addition, subtraction, multiplication के लिए होता है. And then बहुत crude way में बता रहा हूँ मैं, there are lot of things goes behind, but saying that it only knows addition is fine. And then you have memory also plays a very crucial role. तो जब मैंने ये लिखा तो IDF PY जो कमांड मैंने लिखा, ये कुछ लाइब्रेरीज खुद का कंबाइन करके, ताकि ये सारी चीज़ें फिर फाइनली एक बाइनरी में कन्वर्ट होती है. दैट बाइनरी गेट्स रिटन. सो इफ यू सी हियर, लेट मी जस्ट पुल इट अप. 2 बाइनरी बनी है. ओके, ग्रैब बाइनरी ELF, yeah, touch display. So I'll do display. ये एक बाइनरी है, ये क्या है, ये ELF आई थिंक होता है लैपटॉप पे, एंड फाइनली it gets converted to this, to 164 kilobyte of some binary data which has been pushed in that microcontroller, microprocessor, and it keeps on running that. But now that we are not using any यहाँ पे कोई ऑपरेटिंग सिस्टम का फंडा नहीं होता है. FreeRTOS एक करके चीज़ होती है, which basically is like there is something you will read about, क्या बोलते हैं उसको, शेड्यूलिंग, टास्क शेड्यूलर ही होता है. एंड इट्स जैसे आप ऐसे सोचो ना कि 2 फंक्शंस लिखे हुए हैं, राइट? एंड थिंक ऑफ इट लाइक दिस. जैसे एक ये मेरा मेन प्रोग्राम है, ये FN1 है, एंड देन आई हैव अ स्लीप ऑफ 3 सेकेंड, एंड देन यू हैव फंक्शन 2. तो होता क्या है कि फंक्शन 1 लिखा आपने, 3 सेकेंड वेट करेगा, फिर फंक्शन 2. तो ये फंक्शन 2 कुड हैव बिन एग्जीक्यूटेड यदि मेरे को, मतलब ब्लॉकिंग कर रहा है ये, मेरे को ब्लॉकिंग बिहेवियर नहीं चाहिए, या फिर मे बी ये 3 सेकेंड इसके अंदर भी रहता तो भी मेरे को ब्लॉकिंग बिहेवियर नहीं चाहिए, यहाँ इसके अंदर होता. तो या फिर इस स्लीप भी हटा दो और विद फंक्शन. तो कोऑपरेटिव शेड्यूलिंग करके एक चीज़ होती है, बाय द वे. या तो जो भी प्रोग्राम आप लिखते हो ना, व्हेन यू गो टू एम्बेडेड सिस्टम या IoT सिस्टम पे जाओगे, तो थिंक थिंक लाइक दिस, ये हम जनरली सोचते नहीं है, बट everything in even in your computer or any hardware runs behind a very big while loop. This is where the game is. एक while loop रहेगा, उसके अंदर you will have some task, and then task scheduling के लिए FreeRTOS हम यूज़ करेंगे. तो इतना तक मेरे को पता है. एंड आगे पढ़ते हैं, क्या बता रहा था. So I had asked you to explain me the memory and all. IDF size पता चल गया. Then it is telling me the inspect element of this object dump. Okay, minus h this. Okay, so this is some kind of binary, and I believe obj dump करके भी हमारा होता है एक binary. Yes, and let's say if I do build touch display elf. Okay, it didn't work. By the way, in this stream it will keep on happening. It is telling me a command of minus h. Oh, so objdump is also working at this, but objdump से अच्छा इन्होंने बोला है जो इनका खुद का है एक्सटेंशा का, हमें वो यूज़ करना चाहिए. तो build slash touch display dot elf. Okay, so it says useful selections, code stored in flash, constant stored in flash. फ्लैश हो गया हमारा डेटाबेस टाइप का या हार्ड डिस्क. then something code placed in instruction RAM, initiated data in internal RAM, 0 initiated data in internal RAM. Okay, do it like this ताकि मेरे को पढ़ने में आसानी हो. Okay, RTC text size VM LMA resort alignment content data dummy alloc must be allocation. Then there is something related to debug. Okay, I don't understand. It says and ELF grep app main. Yet nothing. Did I not use pipe properly? No. There's nothing related to main. To see the app main ended up symbol as this. It says try this command. Okay, we got something. Task generic notify given as okay. For the both ports, we should record board name, chip name, flash size, PSRAM, USB serial path MAC, onboard GPIO, available safe GPIO. Okay. So this we already did, right? So you have to set this. It is going to basically build that. It will include all the libraries. Okay. No, I want to actually understand कि हो क्या रहा है. I understand this much कि ये मैंने library जो लिखी है. Let me ask this. I am interested in how the language source code gets converted into a binary and flashed to ESP32-S3 works, and also explain ESP32 ESP-IDF. What does it contain? So while it does that, there is something that I had explored. I'll explain that part. Okay. इसको जब तक मैंने बोला था I'll treat it like a link PDF and your ESP32 is most likely a development board built around ESP32, which is a microcontroller SoC system on chip, CPU plus Wi-Fi plus Bluetooth module and memory interfaces, hardware peripheral in one chip. It's not like Raspberry Pi. It doesn't run Linux. Yes. You flash your own firmware directly onto it. That firmware controls the hardware. तो सॉफ्टवेयर होता है, हार्डवेयर होता है, बीच में होता है फर्मवेयर. The ESP32-S3 has a dual core. This I know. This we know. 16 MB flash, 8 MB PSRAM. Octal SPI. SPI is the protocol, right? SPI protocol. Yep. Synchronous serial peripheral. Here you have a clock, input, output, and there SS, I think select signal or something. Yep, slave select, chip select. And so does that mean I can connect like multiple hardwares and select particular chip? Okay, we'll get into that later. Flash where firmware PSRAM, extra RAM for big runtime buffers. SRAM is fast, internal RAM much smaller. Okay, board chip versus module. This PDF shared is this chip, and okay, maybe I should hide these things. Okay, the PDF you shared is mainly USB 2 voltage 3.3 controller, USB to serial pin, सॉफ्टवेयर मेंटल मॉडल. या मैक में होता है प्रोसेस, ऑपरेटिंग सिस्टम, ड्राइवर, हार्डवेयर. 32 में होता है फर्मवेयर, आर्टोस. Yes, I don't think even RTOS is required, because from what I am understanding is it is a scheduling, it's a scheduler, right? I can schedule, like it's a program which keeps my, it's like a meta program which keeps my program capability of writing tasks. एक तरह क्यू सिस्टम भी बोल सकता हूँ मैं. इवेंट लूप नोड.जेएस में जो होता है वैसा ही है ये. You write C++ when it gets compiled and then you flash it to the board. Okay, a simple program like this. Init storage, init GPIO, init Wi-Fi. Okay. Okay. While you read the sensor, send the data to the server, blink LED, and we task PDMS to tick. Millisecond to ticks. Okay. As per in real ESP-IDF, you will use task, events, queue, timer. What this board is good for. We also fix the thing. We should have this. तो आईडीएफ एक तरह का हो गया कि बहुत सारी फाइल्स लिख दी गई हैं पहले से, ताकि डेवलपर्स का काम इजी हो जाए. That's what I'm understanding. What you should care about first is ignore 80% of the data sheet for now. Care how to flash, GPIO, turn on, turn on, serial logs, device communication, I2C, SPI. Okay, these are protocols. UART is universal asynchronous RxTX. UART. RxTX को क्या बोलते हैं? Receiver transmitter. Okay. I2C is there, SPI is there, display SD card, Wi-Fi hai, HTTP computer, do not start with that. 197 is this. Okay, let's go deep into ESP32 IDF and raw hardware. How do they communicate? Walk me through their library. So while it does that, I wanted to show it to you guys this. So okay, now this is the firmware one, right? Yeah, I'm not interested in this. This is my application one. I'm interested in this. Yes. तो ये है, ये टर्मिनल है, तो इसको यहाँ रखते हैं, इसको इधर रख लेते हैं। ये मेरा प्रोग्राम है और ये टर्मिनल। तो ये IDF जो है ना, ये लाइब्रेरी, गिटहब पे जाओगे आप तो भी आपको मिल जाएगा। ESP-IDF what we are doing is we are trying to understand how things work internally, so that, see, my end goal is not to build something बिना समझे हुए. I want to understand ताकि, and this is for anything which you do, the advantage that you get is you are able to write more clearly because you understand the system, right? So ये है इनका developer portal. Welcome to IDF, the priority development framework, production grade SDK for specific software. One framework, many chips. Yes, I know it supports all of these boards. And we have currently ESP32-S3. Yeah, this one we have. So we downloaded it, but built it. And I want to understand what is inside that. ठीक है, इसको पढ़ते हैं. Yes, let's build the mentor model first. C source code, you write this human readable code. This is the file. Ingest text. You cannot run C text, right? It can only execute machine instruction to its CPU architecture. C. The compiler converts C into CPU specific instruction. तो होता क्या है ना, we generally forget कि क्या क्या चीज़ें चलती है. For example, if I, let's say, just write a touch a.c or temp.c, and inside that, let's say I do something like hash include stdio dot h main, then you do printf application started after 0 this it wrote quit gcc temp.c slash a dot out application started. But what happened behind the scene वो समझना हमें जरूरी है कि मैंने लिखा C code which was simple as this, and GCC actually जो GNU की कंपाइलर है C के लिए, your hardware layer only knows how to run binary instructions या instruction set के defined जो rules हैं उसके अनुसार that runs. So whenever we compile something, it gets compiled for that particular hardware plus operating system दोनों combined करके. Yes, I think that's what my understanding is. If anyone knows better, please correct me, क्योंकि I'm just exploring. So when we write all of these things, when we are working in the industry, we generally don't tend to think about uh, hardwares because there's a lot of abstraction that has been done. So my laptop has like Mac OS, right? So it's a OpenBSD based operating system, but it also has hardwares, and those hardwares have their own instruction code. That instruction code, this compiler basically does that, वो उसको convert करता है. So if I do a hex dump c a dot out, तो ये finally कंप्यूटर को दिखता है, वो ये रन कर रहा है. It doesn't know shit about C. Laptop doesn't know about C. C is a human language. All of your programming language is human language. So this is what it was saying. Ki ESP32 cannot run C text. It only runs executable machine instruction for its computer. ESP32, and this is that. तो हम थोड़ा ये भी देख लेते हैं. एक्सटेंसा एलेक्सिस 7 क्या है ये. इतना अंदर नहीं जाते हैं, बाहर ही थोड़ा पढ़ते हैं. It's a hardware that can be programmed. The CPU, programmable embedded processor है. ठीक है. So आगे पढ़ते. The compiler C converts C into this, and that compiler is this. तो जो हमने अभी किया था, okay, it has a help section. Does it have man? So this is now compiler is also a program. तो इसको आप बोल सकते हो कि you write something in one language, human readable language. Compiler is the one which is converting that into binary instructions specific to your hardware, and this is the program that does that. And you guys might also have a question ki generally problem क्या है कि if you have a hardware which is this my M4 Mac, how can I write a program that can run on a different type of architecture? जैसे मैं दूसरे लैपटॉप के हार्डवेयर सिस्टम बहुत अलग हो, उसके लिए नहीं लिख सकता. तो दिस कॉन्सेप्ट ऑफ टूल चेन gives you that capability. GCC, it is a cross compiler, means runs on your Mac, produces code for, it's a cross compiler. Okay, so cross compiler is something, लिख लेता हूँ ये कहाँ का है. ठीक है, runs on your Mac, produces code for ESP. Your Mac is ARM64. Yes, ESP30 is extension. Normal Mac C-Lang produces the final firmware for ESP32 unless configured for an embedded cross tool chain. Compiler input is this. Compiler output is this. Object file. .obj file contains machine code, but it is not complete program yet. Oh yeah. Okay. Each C file becomes an object file. For example, this becomes okay. Also combines many of its own. Okay. So this is the compiler. I think इसको draw कर लेते हैं, ज़्यादा सही रहेगा. Array draw, the best tool. ये मेरा compiler है. ये C, write it as my C code. So I have clarity. कहाँ से क्या चीज़ें इंजेक्ट हो रही है, or I'll just give it a new color. Okay. This is the compiler. This is my code, and this is ESP-IDF C codes, and I'll make it little big क्योंकि ये framework है, and I'll add a lot of smaller codes here, like components बहुत सारे. ये एक तरह का लाइब्रेरी टाइप का हो गया. ठीक है, फ्रेमवर्क है, सॉरी. हाँ, लाइब्रेरी फ्रेमवर्क में ज़्यादा कुछ अंतर नहीं होता. जस्ट इट गिव्स यू प्री डिफाइंड set of ways of doing things. That's the major difference between library and framework. ये यहाँ पे अच्छा नहीं लग रहा है मेरे को. So this is what it was telling कि these two goes here, and then what is it telling कि it produces object file. ESP-PDF also compiles its own C file, and ये सारे इसके C file है. लिख देते हैं. ये IDF का खुद का C codes है. Each becomes an object file or a static library. Okay, so all of this gets compiled into their own. This is my object file. These are like so many. I think मैं ज़्यादा टाइम इसमें ही दे रहा हूँ इसको, but ठीक है. This is important. ये ऑब्जेक्ट फाइल्स हुआ. ओके, और स्टैटिक लाइब्रेरी. स्टैटिक लाइब्रेरी. Static libraries are .a files, either .a or .obj. ये फाइल्स बन रहे हैं. तो ये मेरा .obj. हाँ भैया, कुछ बोल रहे हैं क्या? वही होगा, आई डोंट नो. This is my C object. Becomes object. So at this stage you have many pieces. Your object files are those object files. Yes, I'll call this stage something like this. Okay. And then the linker. Yes, the linker combines all the object files into one full program, which is ELF. This was so far. My code, all of these code will get combined to produce a ELF. So this was like a compile. And particularly we have a linker here. This linker is basically producing that. .elf or .elf. Just put this. Okay, we can put these things. You can just delete these things. लिंकर का नाम नहीं लिया हुआ है, but I believe that will be part of this compiler. That's how इधर होता है हमारा. Does it have a linking space to grep link? Yes, you have a linker. It's a part of that. Generally GCC mein you have a similar structure. You have one driver and then rest of the things. But this is yeah. I can just copy this thing. Right. So then we have ESP32 ELF file. ELF क्या होता है? ELF file. An ELF file is a standard binary for executable programs and libraries on Linux system. FIR and FIR first information is a police computer recording. What? Oh, I thought it was hallucinating. Okay, yeah, executable and linkable format. Oh, okay. By the way, whenever you are learning something, spend some time in understanding the name because that उससे क्या होता है concepts ज़्यादा दिन तक दिमाग में रहते हैं. For example, I remember when I was investigating Brew, which is like a package manager for Mac. It was uh, not by Apple, but well accepted by community. Third party too. So, unka naming convention is very interesting. So they have cask, they have bottle, they have brewery. Brew is the product, and they have uh, the shelf. Shelf को भी कुछ बोलते हैं वो लोग. ऐसा करके है उनका बहुत अच्छा. So ELF is executable and linkable format. It's a standard binary format used by executable object codes, shared libraries, and core object dumps Linux and Unix operating system. And ELF is divided into three major segments: header, program header tables, section header tables. Okay. Okay. ठीक है. Let's go back here. यहाँ तक समझ में आ गया था हमें. The linker also decides where code and data live in the memory. Okay, so this is also important. Let's put it here. Linker also decides where code and data lives in you. This is controlled by linker script from ESP-IDF. For example, a memory layout for ESP32-S3. The ELF file is the most important inspection artifact. Built into this, it contains machine code, data, symbols, debug info, section layout, and memory address. This is where you can inspect something like this. Aha, I remember. So we wrote that C program here, right? There is an interesting thing. So a dot out. Oh, no, I have to do compile it into an object file. -c temp dot c -o dot o. I have the object file nm temp dot o and nm a dot out is also not working. nm inspect C program. Does it give you program or library? Static library. nm command is powerful. It's operating system symbol table of binary. अभी देखो जैसे मेरे को symbol table ये सब concept ज़्यादा clear नहीं है. So maybe I'll keep on learning those. Clear हो जाएगा आगे. Yeah, it's saying to do that only, right? nm temp.o. and nm minus c nm minus C dot. Why? है इसमें right? And then shift D and then okay. Maybe in that terminal I have sourced that thing. That's right. Okay, no issues. This one I have nm dot o. All right. So we are now looking into the object file. So it has main and printf. We do something like this: main temp.c dot c. How about we define something like a void print hello. It takes a argument and it prints. Do I need a pointer? If it is a string, maybe I do. ठीक है भी कॉन्सेप्ट मेरे उतने स्ट्रांग नहीं है अभी but hello percentages name. I don't think it needs to be a pointer, but then there is no concept of it will be a pointer because there is no string, can see, right? It's just an array of characters. Now I will call print hello ww w. Okay, end of the line. Yes, then freedom. Right. That's what keep happening when you're learning multiple languages at the same time. Print is in Lua. So for streaming right now, I had to write a Lua script for that timer. Anyway, gc minus c temp.c minus object file. Yes. Now let's do nm of that object file. All right. So we wrote that. What my understanding now is कि यहाँ जो भी हम फंक्शन वहाँ लिखते हैं वो यहाँ पे nm पे दिखता है. Do we have yes display name list is symbol table as execute default llvm nm. Okay, and cool. Now coming back, so similar to that we have a इसको बंद कर देते हैं. यहाँ पे इनका है and then we have build touch display touch display. Why is it not showing? I think कुछ तो problem है. ls is working. cd build dot touch idf dot py build. We build it again. Okay, so it build it. Now let me do it was something related to build. ये इतना scroll नहीं कर पाऊंगा मैं. Let me do it again. Yep. So similar to what we saw in our normal C program, object file में क्या क्या functions थे कोड के, सोर्स कोड के, वो हमें पता चले, right? So I'm thinking based on our diagram मेरा कोड और ये सारा कोड जो है, all of this is in this kind of object file. No, it is not an object file, but it's a executable and linkable format. तो इसके अंदर हमारा मेन भी होना चाहिए, राइट? मेन, no, main task is there. Okay. Is it because it is an app main? We found it. Okay. So ये सारा चीज जो है, this is coming from ESP-IDF, and if I'm not wrong, these are must be functions, right? Is it like sorted based on, yeah, no, yes, EF G H I J K L M N O P Q R, yeah, sorted based on this. Okay, so if I take this, and if I go to that library ka code, source code, yes, and if I do here, if I try to find this, okay, so this is written somewhere here, at least dynamic library functions. Look at this. This is a test file. Not interested in save test file. libgcc. Okay, let's see what other thing we can drive from here. Yeah. It says symbol A, right? Symbol A का मतलब क्या होता है? Maybe उससे कुछ पता चले, right? Does A means A uppercase is for absolute. This means the value of the fixed permanent value and will not change. So it's like a const, and that's what we were seeing. And I was looking for it as like a function. It's not a function. It's like a, what other thing we can drive? दो दूनी चार, दो तीन छः, दो छः आठ, आठ है, राइट? तो मतलब 8 हेक्साडेसिमल, मतलब हेक्साडेसिमल मतलब ये 2 होता है 1 बाइट. So this is 4 byte. 4 byte is 32 bit, yes. So it's a memory address, and we know extensa is 32 bit CPU. Okay, so it could be either an address or it could be a value. Another thing you have to keep in mind, address and data, even though हमारे perspective से different है, but हार्डवेयर के perspective से भी different है, but think when you write a C program जहाँ पे pointers में लोग फंसते हैं, so you write int a is equal to 10, then 10 is the value, a is there, but it needs to be stored somewhere, right, in that memory. वो मेमोरी का एड्रेस भी जो होगा ना, इफ़ यू आर ऑन लेट्स से 64 बिट कंप्यूटर, तो 64 बिट का एड्रेस होगा वो प्रिंट करते समय नहीं आता है, प्रिंट करते समय उतना पूरा नहीं दिखाता है. तो यहाँ तक हम लोग थे. तो दिस इज अ वैल्यू. लेट्स सी व्हाट अदर थिंग्स वी आर एबल टू सी. T, capital T, assert function. So this is definitely a function. Let me see in the source code. Do we have assert fn? Okay, I didn't copy it properly. This is double underscore assert fn. That sounds like some kind of test. Assert fn. Assert fn only, right? Func. All right. So this is actually a function. And this is defined in assert.h. This. No. This is the definition. This is entire function is this. Assert.h. And this is inside tools, VLAN. I think we are more interested in finding all these things under ESP-IDF. So because some of the results are coming from different folders, I'm not interested in that. तो हम क्या करेंगे? क्विट करेंगे, इसको क्विट करेंगे. Let's cd v6.01 ls cd ESP-IDF and we'll do this at fg and we'll do assert fn func plus func. See, now the results are better. These are the docs. तो component के अंदर ये सारे. Okay, this looks like a very common function. Oh, there was something just interesting. Is it like an address where this functional logic will be stored or something? Let's do something else. T तो डेटा है, रिकॉर्ड नहीं कर रहा. ये इस कंसिस्टेंट. हाँ, ये तो बहुत लोग बना रहे हैं. Like it's a DIY friendly thing. लोग डेस्कटॉप डेस्क पे रख के. क्या?
मुझे नहीं लगता है कि इस तरह का
हाँ
प्रोडक्ट
हाँ हाँ.
रिसेप्शन पे इट इज
Yeah, 100%. 100%.
कैसे ला सकते हो रियलिटी में कॉस्टिंग इसका या फिर कुछ ऐसा ऑलरेडी एग्जिस्ट कर रहा है तो
हाँ, ये तो मैं बना दूंगा, ये बन जाएगा.
क्योंकि पेशेंट रजिस्ट्रेशन
पॉस मशीन का ही कन्वर्जन हो गया, मोर इंटरेक्टिव वे विद एआई. यस, ठीक है. टीम पे लीक हो जाएगा आपका आइडिया. ओके, टी हमने देखा था कांस्टेंट था. ये क्या है? स्मॉल टी क्या है? स्मॉल टी का मतलब क्या होता है? व्हाट आर द कॉमन सिंबल्स टैग आई शुड नो explain them, what they mean. Okay, T is text meaning executable code. Oh, so this could be a function. Aha, it need not be just function, it could be a statement also, I believe. That's why they are saying text, not function. D is for data, B is for binary, C is for common, utilized, unutilized block, static variable not marked, read only, linker and explainer, U undefined, A is absolute. Okay, तो E हमें पता चल गया, D है, B है, R है और S है. E हो गया टेक्स्ट के लिए, D हो गया डेटा के लिए, B क्या था? बाइनरी. What was B? BSS, block started by symbol, global static variables that are either initialized or set to 0. Why are you calling it BSS? Like bullshit. Block standard for symbol. Okay, I'm ignoring that because मेरे को नहीं समझ में आया वो. R is for read only data. Okay, const int maximum makes sense. S is for, there was no S, I hallucinated S and we blame AI for that. इंसान भी तो hallucinate करते ही रहते हैं यार. A is for absolute. will print so up u in your object file. Okay, calling printf malloc will always show up as u in object file, meaning okay, this sounds like important. U is undefined, the symbol is used here but defined somewhere else. Function or global variable that specific file needs, but the code lives in a different C file. All type of headers, the linker must resolve these before the final program. Okay, but isn't object file? Okay, no, object files are not. Okay, so this is not my complete code. It didn't say that, but ELF is supposed to be my complete code, right? It is not directly the flash image. Okay, ठीक है. So we wanted to explore little more based on the tags. U is undefined. Okay, we have data. Something is going on here, which I don't understand. D, we have B, we have A. A is for absolute. We are looking for T, right? Because T is the interesting one. T are the functions. We understand function. Pow 5-bit sounds like power of a 5-bit number. We can find that. Okay, pow 5-bit is not there. Pow 5 multiplication is there. If it is not in the source code, where is it coming from? And this, what I am also seeing, is just an address which is defined in. Okay, I need to reconfigure this thing to see the. I can do this and I can see this LD file. Okay. ठीक है. Power 5 factor. This is also a function. There's only power 5. Where is everything? Is it even searching everything? Let me do this. Okay. Is it because of get ignore? ये सर्च ही नहीं कर रहा. बट इसमें सोर्स फाइल तो होगा ही सारा. तो ये जो पूरा लिखा हुआ आईडी है, दिस इज आवर लाइब्रेरी या फ्रेमवर्क. फोडू लोगों ने लिख दिया है ताकि हम ये लिख पाए. ओके, एनीवे नाउ तो ये हमें समझ में आ गया. दिस इज ह्यूज. ls minus h build. ELF फाइल जो है कितनी 3.6 MB. ओके, ठीक है, यहाँ तक पढ़ लिए थे हम. लेट्स गो बैक टू आवर डायग्राम. तो यहाँ पे थोड़ा थोड़ा हमें समझ में आ गया कि यहाँ से वी कैन बेसिकली डू एनएम टूल और स्पेसिफिकली बोले तो एक्सटेंसा का एनएम टूल विच टेल्स अस अबाउट सिम्बल्स एंड ऑल. ये भी थोड़ा देखना पड़ेगा सिंबल विम्बल क्या होता है. ओके ओके ओके, इट इज़ गिविंग मी अनदर ऑब्जेक्ट डंप कमांड ऑल्सो. ये भी ट्राई कर लेते हैं. ओके, दिस इज डिफरेंट. आईडी name, size, VMA, LMA, file of alignment, LGN, object dump. 1 second. Mass .elf 3.6. This is all 00024, and this is again 2 4 6 2 8, and 8 का मतलब 4, 4 का मतलब 32. It could be a value or address is what I'm understanding. ये सारे एड्रेस हो सकते हैं. Yes, these all could be address. And then you have idf.py size. Oh, जो हमने ऊपर अभी यहाँ देखा उससे रिलेटेड है. Executing action size, running ninja in the directory. So ninja is another, like, it's a build tool similar to make, and you write the build कैसे करना है. cd this, it did something like this. Smallest app partition is these many bytes. Bootloader size is this. Okay. Flash code 65,174 dot text dot data dot bss. Oh, all of these are that code we were seeing, right? Total image size is 16. Okay, 164 KB. उसी से related है ये. 164 किलोबाइट. तो ये 164 किलोबाइट का जो बाइनरी बना है, that information is here. You have flash code, you have DRAM, flash data RAM. Okay, क्या है? I don't know. But sometimes when you are learning things, there are things जिसको इग्नोर करके आगे बढ़ते जाना चाहिए, एंड जहाँ पे टाइम इन्वेस्ट करना इम्पोर्टेंट है वहाँ करना चाहिए. ओके, तो बाइनरी इमेज ELF is great for debugging, but it's not directly the final flash image. ESP-IDF uses ESP tool to convert ELF section into flashable binary. Okay, so we have another tool called ESP tool. Maybe here this thing will go थोड़ा छोटा कर, वैल्यू अब कम हो गया. ESP tool is cool. This guy will take this, will convert it into a dot binary. Star dot binary. I think यही हुआ अभी तक, right? Touch display ELF. This, and this is our plan. The binary is what gets written into the ESP32 flash. So ये बन कैसे रहा है वो हमें पता चलेगा. This is where this binary is getting written. ये binary का साइज कितना था? 164 किलोबाइट of data gets written. When you do this flash ESP tool.py talk to ESP30 ROM bootloader over USB serial. center to access the flash comments writes multiple binaries to specific flash address. Okay, this sounds important. ये लिख लेते हैं. I think ये important है. So when you run IDP flash, what happens is ESP-IDF जो फ्रेमवर्क है, तो ये एक प्रोग्राम है. प्रोग्राम को आर्ग्यूमेंट दिया मैंने फ्लैश. वो प्रोग्राम एक पाइथन फाइल उठाता होगा जो कि रोम बूट लोडर, एक रोम है रीड ओनली मेमोरी, वो सीरियल. ESP32 has a small bootloader permanently burned into ROM at the factory. तो एक प्रोग्राम उस पर ऑलरेडी एग्जिस्ट करता है, वो है bootloader. When the chip enters download mode, the ROM bootloader listens over USB UART and accepts flash command. Okay. ESP-IDF writes multiple binaries to specific flash address. Okay. But I believe it cannot write it to ROM, right? So it must go to either flash or RAM. Flash address. And it says flash address. So मेरे ESP32 के flash address पे this thing is going. And here bootloader.bin multiple binaries. Interesting. We were under the impression that there will be one binary file, but there are multiple binary files. Okay. And last में मेरा file गया है. And you can see the exact addresses here. Cat build flash. Okay. Let's see. Cat build flash args. So there are actually multiple binary files. So let me correct this. The binary that gets multiple binary files is what gets written into the ESP32 flash. So यहाँ पे ये है, and this is my board with ये उसका board का memory address, memories है, and these are 32-bit memories as per our last understanding. So कुछ कर सकते क्या ताकि कलर लगे दिखे. This is black. We can write another binary. Let's do it this color. Okay. And इसका नाम भी दे ही देते हैं so that it is easier. So let's do something like bootloader. Why I'm giving names here ताकि easy हो समझना हमें. तो यहाँ पे ये गया and it goes at this address 0x34. एक्चुअली 8 होना चाहिए बट ठीक है. तो इस एड्रेस पे यहाँ गया. और सेकंड है अपना पार्टीशन टेबल. अब ये प्रोग्राम है क्या वो हम थोड़ी देर में एक्सप्लोर करेंगे, बट these are the binaries that is getting written, ये हम श्योर है. Can we make it bigger? कुछ बटेगा. पार्टीशन बाइनरी एंड इसका एड्रेस है ये फिक्स नहीं है बाय द वे. दिस इज स्पेसिफिक टू आवर प्रोग्राम कि ये हमारा जो आउटपुट आया है उसी को कॉपी कर लेते हैं. ओके. So this is where this is getting written, and then we have यहाँ पे मेरा बाइनरी जा रहा है, राइट, एंड इसको बोलते हैं फ्लैश आर्ग्यूमेंट. ओके ओके. I should have done like this. This is much better. Oh, I can still do this. Okay. ये बाइनरीज बनी. और ये कमांड हमारे लिए इम्पोर्टेंट है एक्चुअली. What do we do for that? ओके, ये भी ठीक है. इसके लिए अलग से रंग नहीं कर सकता मैं. रेड पूरा ही हो जाता. ठीक है, कोई दिक्कत नहीं. तो थोड़ा छोटा कर देते हैं, हमें पूरा विजुअल देखना है कि वो क्या रहा है. ये जो लाइन है, because that is important. Build last dot and object dump. ठीक है, इसको डॉक्यूमेंट करने का काम कर लेंगे बाद में. बट हमें ये समझ में आ गया कि अलग अलग बाइनरीज बनी, बट वो बाइनरीज यहाँ विजिबल हैं क्या. ls माइनस lh build star dot bin. No, I see only one binary. There are other binaries. 3 minus 11 10. I don't see that binary. Oh, bootloader binary. एक मिला. How many we had? We had 3, right? Partition अपने को ढूंढना है. Partition. We found the binary. It's nested somewhere. Is there any way I can do like minus something? grep में होता है, वो ऊपर नीचे का लाइन दिखाता है. अच्छा, no issues. We have our crazy ass. touch command. This is my source code. कुछ छुपा देते हैं, कंफ्यूजिंग हो जाएगा नहीं तो. यहाँ पे हमारा सोर्स कोड है. हाँ 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 हाँ, ये है लाइब्रेरी. राइट, यहाँ पे कैसे मिलेगा भाई. तो गलत ही फोल्डर में आ गया ना मैं. तो बंद करो. यहाँ पे मिलेगा ना जहाँ पे सोर्स कोड है मेरा. हाँ ठीक. ओके, ऐसे भी नहीं, अपने को ढूंढना पड़ेगा ऐसे में भी. बिल्ड के अंदर की चीज़ें आई थिंक ये नहीं सर्च करता है, क्योंकि वो गिट इग्नोर में डाला हुआ है. मे बी बिकॉज ऑफ दैट. लेकिन यहाँ गिट इग्नोर तो है ही नहीं. ये यहाँ पे क्या कर रहा है? यहीं पे लिख दिया था मैं, ठीक है। ओ, it's funny like this is our source code and we are trying to figure out कि कैसे क्या चल रहा है। 3 minus L10 is all the file, and then we did grep again, it shows us this. Okay, right, तो 21 KB का ये है, 21 किलोबाइट का, ये 164 बाइट का। हमारा मेन पूरा प्रोग्राम कितने का था? 164। हाँ, ये 164 का है। अच्छा हाँ, ये 100। Oh, 3 different binaries, right? So on this binary and this binary and this binary, these are the 3 binaries that gets loaded to specific address, ठीक है। ये हमें समझ में आ गया, तो यहाँ तक ठीक है, आगे पढ़ते हैं। After flashing, when ESP32 resets, computer starts executing ROM bootloader inside the chip, जो तो उसका खुद का है। ROM bootloader reads second stage bootloader from flash at address this. हाँ, तो दिस इज माय, इसका खुद का एक बूट लोडर है जो कि स्टार्ट होता है एंड इट सेज कि हे, let me go and invoke this guy at this address. So whatever I put it here, if I have put, so that's why I was saying कि understanding the basics is important. So this is my ROM boot loader and its job is to basically wake up and start running wake up, go to this address and start executing. So if I just put some machine instruction which does just one thing, then, and if I put that here, that could also work if I don't want to use any IDF and all. So after flashing, when ESP32-S3 resets, this was, we were there, right? ROM bootloader reads the second stage bootloader from flash at this. ESP-IDF bootloader reads partition table. Now this guy will read this guy, क्योंकि यहाँ से यहाँ तक में तो ये खुद का प्रोग्राम रन किया होगा और उस प्रोग्राम में लिखा हुआ होगा कि कहाँ से स्टार्ट करना है, तो यहाँ से स्टार्ट करना है। एंड फ्रॉम हियर boot loader finds app partition usually at 10K and this is where app partition starts और यहाँ पे हमारा कोड है। The bootloader loads and start your app. ESP-IDF startup code initializes the memory, clock, CPU, heap, FreeRTOS. FreeRTOS starts. ESP-IDF creates main app. Main task calls your ape man. Ape man, not ape man. App main. What is that? There's so many things that is going on. I want to put that here. Where did it? Can I just put an image here? Aha, nice. And apparently I don't know how to. Yes, maybe I should have done this. So boot process is very important to understand. What my understanding, थोड़ा ऊपर कर लेते हैं, अपने को ये समझना बहुत जरूरी है. So after flashing, when ESP32-S3 resets, CPU starts executing a ROM bootloader inside the chip, which is burnt into the silicon. So now that CPU starts executing the RAM bootloader inside ROM bootloader. ROM bootloader reaches the second stage bootloader from flash. This is your second stage bootloader. At this address, ESP-IDF bootloader reads the partition table. Partition table अब क्या होता है? I think some kind of memory को partition करने का होगा, file system. Then partition table, bootloader finds app partition, usually at this address. Bootloader starts your app. ESP-IDF startup code initializes memory, clock, GPU, heap, and FreeRTOS. Okay. So this binary, what I have written, apart from ये सारा चीज जो ESP-IDF से generate हो रहा है, this would also include ESP-IDF framework source codes, right? But if I have not included anything in the header, then why will it? Because this is just a blank, right? So if I compile this, whatever object code or even anything that gets generated will not have framework, right? Anyway, FreeRTOS start ESP-IDF creates. तो IDF का source code एक तरह से समझ लो कि framework का भी initialization है, where the framework is doing what? Framework, यदि हम source code जो देख रहे थे, it will go here. All of these components are nothing but HAL based things, right? HAL is hardware abstraction layer, where it is talking to those specific registers, and to do that, so for example, it's a driver UART, universal. ये जो communication है, this is still happening via physical signals और hardware के pins को voltage control करके, right? But how do you do that? You need to एकदम lowest level पे, if you have to go, you will be writing something very low level which will control those signals, and to do that you have to have connection with the initialization with the hardwares, I believe. So this is doing all that. FreeRTOS start ESP-IDF creates main task. So your main task is directly not starting. So what my understanding is, we can still do all of this without using FreeRTOS. अभी डायरेक्टली वो नहीं करेंगे, पहले हम लोग पहले विल डू what is told and then we'll play around. Now, so your app main works because ESP-IDF built a whole embedded runtime around it. Okay, ESP-IDF is not just a development framework. Okay, I think we have had enough. थोड़ा break ले लेते हैं. I will keep this on the screen for anyone who wants to revise, and apparently अपने पास not much people, but yep. So this is what we discussed so far. I'll take a break. So I'll just walk you guys through again क्या क्या अभी तक हमने देखा. This is what my source code was, which is just this, an empty app main, and then we had extensa compiler GCC, similar to, is there any way to like lock it that I don't want it? extends a GCC similar to our GCC. It compiles our source code, and uh, it generates ESP-IDF C code उठाएगा, जो कि ये सारे थे FreeRTOS ESP system log heap, all of those components source code which we saw, which is available in GitHub here. It combines all of that and creates object files. My C object. So this is my object file, and then we have object files and static libraries. Now these two will get combined by linker to build a binary. Not binary, it's a ELF. This ELF, the linker also decides. Acha, the linker also decides where the code and the data lives, which we can see via this command. Cat build flash arcs, and in that command we saw, well, it is, yes, that. So after this, ESP tool basically generates multiple binaries, and these binaries are basically written in the hardware. And there we saw ROM bootloader, which is put it in the silicon chip of the controller that starts reading from here. Then all of these happens, and between this and this, there's a big chunk of ESP-IDF hardware initialization process that happens, plus the software layer, because of FreeRTOS also starts, and then your finally app main runs. So we have covered this much. Next, after the break, we'll discuss this part, what ESP-IDF contains. I will just no. Both screen is working, right? So I can just maybe play some song. हेलो। यस। तो हम लोग कहाँ तक पढ़े थे? ESP-IDF जो है मल्टीपल बाइनरीज जनरेट हो रही थी। यहाँ पे हम लोग बूट प्रोसेस हमें समझ में आ गया था कि बूट प्रोसेस में क्या हो रहा है. What is ESP-IDF? ESP-IDF is not just a... Okay, by the way, let me... Thomas was saying कि वो दिख नहीं रहा है. And increase the size of it so people can read a little bit. मेरे को दिक्कत हो रही है. छोटा ही कर. Yeah. So ESP-IDF is not just a compiler, it is a full development framework. Yes, we had agreed on that. It contains build system, toolchain integration, bootloaders, startup code, FreeRTOS, hardware drivers, networking stack. अब ठीक है, मेन तो ये है राइट, ये और ये, बाकी तो सॉफ्टवेयर लेयर हो गया. दिस इज वेयर एक्चुअल थिंग हैपेंस. देन मेमोरी एलोकेटर, ठीक है, वो हार्डवेयर ड्राइवर का ही पार्ट आएगा. सी लाइब्रेरी इंटीग्रेशन, पेरिफेरल APIs, एग्जांपल्स, कॉन्फ़िगरेशन सिस्टम. Important folders inside are components, tools, examples and docs. So we'll go to our source code. यहाँ पे ये बोल रहा है examples, tools and components and docs. Oh, we have a document also. Oh. We should have started from here. This folder contains the source file of ESP-IDF documentation available in English and, no offense, maybe Chinese. I don't know what that is. The sources do not render well in GitHub and some information is not visible. I do not use actual documentation generated within 20 minutes on each commit. After you click any of this link, let me think what it is. Getting started. Okay. I don't care. Pip install is docs, build docs, documentation. Oh. समझ में नहीं आया. Anyway. S3 नहीं है. Doxy file. आता है doxy file. Headers कुछ है static है. Maybe there is a good documentation inside here, but I'm not interested in that because code देख के समझना is much better. Maybe we can look into the examples. Simple example कुछ है क्या? अच्छा, ब्लूटूथ का एग्जाम्पल है, बिल्ड सिस्टम का, कॉमन कंपोनेंट्स, इथरनेट, गेट स्टार्टेड, ब्लिंकिंग लाइब्रेरी and hello world. Hello world is, I believe, the first thing, and it is this code GPIO.h, int types.h, SDK config.h, FreeRTOS task, ESP chip info.h. हाँ, ये कर सकते हैं हम लोग. Okay, let's do this. I think we have understood enough to start writing our code. Hash include ESP info, your project info, chip info dot ESP chip info dot h. I got it. And so and we'll explore that header also. So we will just this here. Now we need this guy here. तो यहाँ से हम लाइब्रेरी की चीज़ें पढ़ेंगे. Command ff ESP chip info h. Yeah, this is the header file. Okay, and it defines, yep, there is a struct. We can see here. This is also a type. So is it defined here? Copy this and do fg on this. Yes. R underscore t. I'm new to this and Vim ecosystem. Just taking me time. So I believe this is a struct type, a type def, where model will have some attributes defined. ESP chip info star t. This is the function that needs to be called, and this is the type. So if I define this here, let me just copy this, paste it here. Oh. It will be okay in some day. Do I copy it? Then why copy it? Copies, right? Okay. This is the struggle that we have to go through to be more efficient. So this is my chip info type. Call it my chip. And how do we get that chip info? By calling this ESP chip info. It will take this, okay, as a parameter. So we'll call this method. Oh, nice. And we'll pass this parameter. It takes a pointer. We'll pass this. It's a void, so it will automatically assign that value to that. And then now that we have the value, we have to log it. How do we log this value? So we need some kind of logger. Was there a logger? Okay, it says printf. I can do stdio and then printf. stdio.h. I can just do printf. Maybe I can do something like this. Printf application started. Something like this. And then I have to print this, but then I'll have to find the type. I did this. If info.course, it will tell me about course features. All of these are big idea of target. What the hell is this? We don't need all that. Features. Is this what my understanding is? Chip info will be one string, I guess. Course is a integer, but features are string, and this must be containing that specific path. But we don't care about specific path right now, so we can just log the whole thing and read it. So I'll do chip info integers, and I'll do ESP chip info T info T dot features. Oh no, that's the type. I don't type. I'll have to do my chip dot feature. Oh, I've written this. We'll ignore the error. Now we'll have to do IDF dot py. We'll build this. And let's hope. Okay, it broke. Just features only, right? Info dot features. And then something inside that. Ah, it's an AND operator. So maybe this and this will have to get into this type, man. ESP chip info type ढूंढना ही पड़ेगा हमें. So can I do something like definition, go definition, reference. Okay, I'll just copy this and do a fuzzy search on this. We got it. So it has features, which is 32. The same thing, right? Yeah. So revision is there. Feature criteria, which is a 32-bit integer. That's why it is complaining. So 32-bit is supposed to be LD. Let's do that. And now that we have read the type, we can also do and paste it here. Please don't judge. I'm still in the transition period. So check info. I'll get better. Yes. And we had number of cores and revisions, right? So revisions is D. Percentage D backslash. And we'll do my chip. Why enters are going like dot? We're getting this now. We have model also. And revisions. Model is Model is the model type only. But how do you print a different type? We'll do course and revision. So we'll do revision first and course. Revision, revision, and then we'll do course. Printf, chip course is percentage T maximum step dot course. We'll just format everything to look nice. And equal to here. Right. Okay, right. Equal. Now we'll do idea by, or we can just do flash monitor. Port is busy, somebody else. It is being used here. Close this port. We'll close this guy. Got it. So I'm so happy. Chip info is 18. I don't know what that means. Revision is 2 and course is 2. So we know dual core is there. 18. What is 18? Chip model. Okay, chip model is also another type. Maybe we can decode that also. ESP chip model. So have they so it's like a enum they have defined. So ours should be 9 because we have ESP32-S3 and this will be what percentage D, but these are integers I believe. T and ESP info underscore T. Am I getting so many results? This one doesn't have, it has only a revision number in the format MXX. Features. Let's go back to the source code and see from the example. So we were able to write this much, right? Where we got the chip features, revision and course. Features. What does feature mean? This was not an, it's a bit operator. Oh, that is so cool. This is bit masking. Okay. Okay. I think I'm getting it. So this is, oh, so this is a cool thing to know. For people who don't know, think of it as like this. You define something like a state is equal to, let's do no. Okay, so A is a state which could be like 10, 18. Now this 18 number in itself is like a binary, right? So binary 18 is what, 16 and 2. So we'll have odd, right? So 1 0 0 1 0. So this is actually value is 1 0 0 1 0. Now each of this flips is basically taking a, so let's say if I do a and binary value, how many bits we have? In 18 we have like 3 to 5 bits, so you get 5 flags, and for each of these flags you get the value. And that is cool. I think that number which we got, we can decode that number. So this is chip info features is 18, so we just need to find the flag for this. That is so cool, by the way. Maybe it is common. I'm new to chip info. What is it? I keep forgetting these things. Chip features. Chip features. Feature Wi-Fi BGN define, must be defined somewhere. So here it is in the info.h. We should have looked into that first. The header file, yeah, it makes sense. So MB flash memory, and how many bit it is? 0 1. Fourth bit is Bluetooth, and they do an AND operation. So embedded flash is there or not, Wi-Fi is there or not, BLE is, I believe, Bluetooth LE is there or not, BLE BT is there or not. And when you do like individual bit, so it's like, I want to make you guys understand, like think of it as like 1010. I'll just do something like this. Let's say 00. Let's do two things. So you have 00, and when you do one moved 1 bit, what it, yeah, fair, one moved 0 bit. So yeah, it's a bit operator. So where is one? One is at 0th position, so it is 0. When you move 1 to first bit, uh, 0 in the index, then first position it is 2. What will happen when I do this? So 1 move to 4th bit. So if it is like a, let's say we have a 8-bit number, so 8-bit number could be something like 1 0 2 2 4 2 6 2 8. This is the 8-bit number. Now if I do and I will AND it with a number which has a 1 bit at first position, 1 bit at, yeah, first position, sorry, double M. Yep. So we got 2. Then I do it at second position. Then we got 0. If I do it for third position, 0. But if I do fourth position, I get that number. So whether a bit is high, a bit. So think of it as like this is your number which has all the information whether some of the features is enabled or not. You can, and you have this like a dictionary to look into that, and that dictionary is being defined here, where you have this, all of these have those informations. So 0 to 7 is like 8-bit. So we have 8 bits of information here. And once you do that, then you can, so chip info dot features. How about we do this manually instead of via code? So what did we get? We got 18, right? I'll just write it here. 18. What is 18 in binary? It is 10010. And we know we need how many bits? 8 bits, right? So 3 do 5. Let's make it, add it with 0. Now we know these things. Where is that added bit? Yeah. So 0th bit is EMB flash. 0th bit, is that 0? Yes. So EMB flash, I don't know what that is. So that we got as 0. Then we have first is Wi-Fi BGN. So first is this one, right? So Wi-Fi is true. True. We got true. Fourth bit is BLE. So 0, 1, 2, 3, 4th. BLE is true. BLE is true. And then fifth bit is BT, Bluetooth. But fifth bit we got 0. So BT should be false. And then we have sixth bit is IEEE 80. IEEE 80. That we also got false. Or PSRAM we got as 7th bit. PSRAM is also false. नहीं, कुछ तो गलत समझ रहा हूँ मैं, because I know PSRAM and everything is there, right? So 0, 1 is there. 1 से 3 तक खाली क्यों? How are they extracting it? मैंने भी तो ऐसे ही किया. Do their way. And flash size also they're extracting. Extract the flash size. Ah, this is another function. ESP flash. इसके अंदर होगी वो लगता है. To ESP flash.h, right? इतने सारे क्यों हैं भाई? ठीक है. Offset and size. ESP flash. यहाँ से फ्लैश का डेटा निकलता है. ओके, मेक सेंस. एंड देन तो ESP, इससे चिप का इंफॉर्मेशन मिल रहा है. ये ESP सिस्टम क्यों यूज हो रहा है फिर? ESP system डॉट एच में क्या डिफाइंड है? ESP सिस्टम देख लेते हैं ना उसमें. ESP system डॉट एच Why do we have so many? एक ही address होना चाहिए, but ठीक है. Reset reason can be undetermined. And ESP error. Okay. Okay. Register shutdown. ESP restart. ESP. Okay, something is important for us. Get free heap size. Free internal heap size. Get minimum free heap size. Maybe they're using that. Told you. And they are using PRIU 32 percentage something. What is this? This is this unsigned N32 bit. Okay. So I think what they have written is much better. Instead of writing the whole thing again, we'll just copy paste this. Acha. There are some data types which I'm not sure why we need. Okay, int types make sense because we are using percentage %d. I did not add that, right? Just these two. My code had worked, right? We'll just copy paste this whole thing. I just don't want to use RTOS right now. So what we can do is we'll just copy this thing. We'll paste it here, which doesn't need RTOS. Paste it here. I'm so not good at this. I actually changed everything even just yesterday. My old configuration was lazy VM configuration, and I thought, how do you copy text? No, at least I know. Why it doesn't copy? It used to copy. So how do we do this? Maybe I'll just copy this file there. CP gets where inside ESP-IDF, right? So examples, examples, get started, hello world, main, hello world.c. I will move it to our location, which is class. I shouldn't have written this. We just does that automatically, right? Class main, and yeah, it's easy. So we have this file. Now we will add our main hello world main C and write it to main touch display.c. All right, we have the whole thing. Okay. What? I'm so not good at it. Supposed to be a stream for load the file, right? So we don't want this FreeRTOS thingy. We don't want this. We also don't want this. I'm not sure what is the need of that. The rest of the things I know that is being used. Till here it is fine. This is fine. This I don't want. This I don't want. This I don't want. This I don't want. I definitely don't want this. Oh, maybe ESP restart was one of the things that was written in there. I've written. I'll do idf.py build. Let's see. Wait, what? Built it so quickly. idf.py full or something. Okay. So we have this directory completely empty. It will build everything. We are doing clean build just to be sure that everything is written properly. And this much we know. This all of these concepts are from C only. We wanted this. Mm. I don't want this. Okay. Now we'll do idf.py flash. We have only one device, so no need to do -p and okay. Hello world, this is ESP32-S3 chip. How do we divide that? Must have gotten from that code. This is a percentages. Chip IDF target. Chip IDF target. It did not get it from the chip. Some kind of value. It could be a macro which got calculated by this after we called this. Can we do this here? Print chip value before chip info call, and then we can do percentages, and I can do config idea because it sounds like it's a configuration that was picked up. Build flash monitor. Does it take a command like this? First of all, the code is not right. built it so quickly. It's like a configuration which was picked up. I think we'll stop here. It'll be pretty late. We'll start from here tomorrow, or should we complete this? There's not much left. Okay, we'll finish this quickly. This one we had learned. This is why empty app is not just a few bytes, it's complete embedded application image. Desktop C versus ESP-IDF C. Desktop C, main C, OS loads the process, OS keeps the memory file, terminal threads, program exits back to OS. App main, don't desktop OS, ESP-IDF initializes the runtime, FreeRTOS schedule. Program normally never exit. This is wrong. It did exit because we are not using FreeRTOS. We don't want it. We wanted to start with very minimal configurations. Hardware is controlled directly through drivers and just the full pipeline. There's a complete pipeline. Touch displays. Compiler we know. Then linker did, and we know that this part of linker was part of GCC, I believe. Okay, now it is telling me to do that, but we already did it. Can you write this was awesome? Can you down all of these into folder called create a folder and put all the above knowledge in our conversation with title, with app title in a MD file. Then I can read later and devise these concepts. Make sure you put the ASCII diagrams and no knowledge should be left out, which you thought fun. By the way, I always get worried when I'm talking to AI agents to tell them last previous because they don't have concept of those words. Sometimes they will understand, sometimes they won't. Okay. Now that was today's session, and we'll continue building on this tomorrow. And once we understand all the concepts that we need to understand related to ESP32, then we'll build some kind of product, not product, because then we'll have a hardware, an embedded system hardware, which we can control, and that's cool. This is my first stream. Thank you so much for anyone who watched. I think there was one time we had a peak 2 viewers count, which is not expected. I don't know who was the second guy. So that's it. See you all tomorrow.